Hi, I'm Dhananjay Pershing, BE in SVC. I welcome you all to my presentation, and my topic is the environmental impact of artificial intelligence. And the contents are introduction, related background working or implementation, application, and future enhancement. Conclusion reference. Introduction. It explores the AI contribution to enhancing energy efficiency, examines the significant energy and water resources required for the training and utilization of artificial intelligence AI system, which consequently result in substantial social cost. John McCarthy was one of the most influential people in this field. He is known as the father of artificial intelligence because of his fantastic work in computer science and AI. McCarthy coined the term artificial intelligence in the 1950s, and in 1952, a computer scientist named Arthur Samuel developed a program to play checkers, which is the first to play checkers, and he is the first to ever learn the game independently. 1955, and the author Samuel is the author of term artificial intelligence. Related background. The environmental impact of AI, the UNESCO recommendation on the ethics of artificial intelligence provides a global ethical framework for AI development and deployment, including environmental considerations. UNESCO means United Nations Education, Scientific and Cultural Organization. AI system requires substantial electricity and water resources, especially with the rise of generative AI guide. According to the IEA, AI contributes to about 2% of the global electricity consumption in 2022. Projections suggest this figure may grow significantly, matching national consumption levels like those of Sweden or Germany by 2026. Water use is also rising, especially due to cooling needs in data centers. For example, Microsoft Google water usage surged due to guide development highlight AI growing environmental impact. Literature survey. Working implementation. AI affects the environmental in three main phases. Model training phase. Training large AI models consumes massive energy and water. Example, training ChatGPT 3 used 1287 megawatt of electricity and emitted 552 tons of CO2. These models also consumes millions of gallons of water for cooling data centers. Inference phase. Even post-deployment AI model use energy. A single ChatGPT query can consume 2.9 watt and up to 500 ml of water. Infrastructure production. Building GPUs and AI supporting hardware is energy intensive. It contributes to electronic waste, e-waste, and requires frequent hardware upgrades. Indirect impacts leads to an increased demand for energy infrastructure, ongoing upgrades, and high conceptual requirement further exacerbate the environmental burden. ChatGPT uses approximately zero point 0.5 or 500 ml of water for every 5, 5 to 50 prompts to answer. This water is used by the data centers that power the AI model mainly for cooling servers. The water consumption is primarily due to the energy required to run the calculation and generate a response. Evaporation. Some of the water used for cooling is evaporated and and lost into the atmosphere. Working implementation contains. The output generated by the ChatGPT model is then formatted and using regular expression to isolate for instructions and remove any unnecessary text. Each step is analyzed by a rule-based model. Each task it with a specific label like start, input, or decision, and assigns the corresponding flowchart shape. These labeled steps become nodes and their logical sequence form the edges of a directed graph. Using this structured format, the graphics library convert the diagraph into a clear and easy, visually accurate flowchart maintaining the logical integrity of the original process. The system user interface built using Gradio allows users to input prompts, view generated flowchart, and download the result in standard format. This interface ensures that even non-technical users can create flowchart or breathlessly. Additionally, the backend supports editable digraph code for customization, giving users more control if needed. The overall pipeline combines NLP, role-based logic, and graph rendering into a seamless and user-friendly experience. Application and future enhancement. Despite its negative impact, AI is also being used to improve environmental sustainability, efficiency gains. Google DeepMind reduced data center cooling costs by 40%. Energy monitoring shells uses AI to track methane emissions. Smart infrastructure. AI supports smart homes, grids, and industrial automation. Sustainable planning helps engineers optimize pipeline and power line layouts. Future trends. ISO is working on a global standard for sustainable AI, and the new regulations like the EU AI Act will require AI developers to report environmental metrics. Conclusion. AI training and usage require vast amount of energy and water with environmental consequences. However, AI artificial intelligence can also support sustainability through improved efficiency in pollution control, balanced development, and strict, stricter regulation. Strict regulations are essential to mitigate its footprints while maximizing its benefits. Reference. Thank